and accuracy. And how are they related to physics?
Big kids, that's you.
You're thinking. What, Laddie?
Precision, like, right on.
No, that's accurate.
Is it the same thing?
The difference between precision and accuracy.
Precision is like spot on though, isn't it? Like accuracy is tight.
You have good accuracy.
So when we're talking about experiments, what do we want? What's the difference between being precise and being accurate?
She knows.
Precise is about like one thing, isn't it? And then accurate is about the general.
How about if we use real life?
Yeah, give an example.
How far is it from here to Gregory? 8 miles. What if I said it was 8.02 miles? Is that more accurate or more precise?
Or precise.
Because precise means
Getting a similar result every time you try.
precise means measured to a finer degree. Precise means it has more decimals on it. If I said it was 100.000009 miles to Gregory, is that more precise than 8.02? Yes, it's more precise. Is it more accurate? Is it accurate to say it's 100.80 miles to Gregory? No, that's not very accurate at all.
What's the difference between inches and centimeters?
What do you mean, Brittany?
Centimeters would be more exact than inches would be because you could give me like it's 5 inches, but it could be like 5.2 or something.
Yes, centimeters are smaller than inches, so that's a finer measurement. Fine means small. So if you use smaller measurements, you're getting more precise, but not necessarily accurate, because 100.000002 is not accurate at all. So what is accurate? Sorry. Upperclassmen?
Is accuracy a location? Landon says no. If I say that I'm 7 foot tall, is that accurate?
No.
Why not?
You're like 5 foot.
If I said that I was 7 foot tall, would that be accurate?
Yes.
No.
Yes.
I'm a hair over 6.5,
Is he
and I
more-
have boots on.
Is that more precise?
More accurate.
Why? Vicki?
You guys are almost there.
You're very, very close.
If you're throwing darts, do you want to be accurate or precise? So accurate means
On the spot.
on the spot.
On the spot.
It means correct.
Correct.
If you are accurate, you are correct. So is it correct to say that I am 7 feet tall?
No.
It is if we're rounding everything off to feet.
How tall are you?
Is feet a precise measurement? No. Is inches more precise? So then we have to go to 6'6" and answer your question and continue the conversation. Right?
So in physics,
Hannah, are you ready?
are you ready? So in physics, do you need to be precise or do you need to be accurate?
Precise. Both.
Yay, Tiff.
Because didn't this experiment show us accuracy? How did they show us accuracy? What 2 words were they defining for us? 6th graders, what 2 words were they were showing us? What 2 forces? What 2 forces did they teach us? centrifugal and what was the center one? Centrifugal.
Okay, I need to teach you the little cheat that I learned in probably junior high. Centrifugal sends you flying. There's an F in the middle of that word, and flying starts with F. If you don't want to go flying off the merry-go-round, what do you have to do? You have to pull towards the middle, right? And pull starts with P, and in the middle of centripetal is a P. Centripetal is the pull towards the middle, and centrifugal sends you flying. You can use the P and the F from the words.
Centripetal as a pedal. In order for a bike to move, they have to pedal the little pedal inside. We good?
Now we'll have to do that.
Now you gotta go to Finder, right down there.
Their experiments, did it show accuracy on explaining centrifugal and centripetal
No, it should be way
forces? The difference between the big merry-go-round and the small merry-go-round? Were they more accurate?
Watch your fingers. See if you move your fingers. Don't drop it. You'll be paying for it.
You got it, because
I would never hold that.
I know, but if you drop it,
There is a she dropped it. I would drop it. I would get
There's two of them.
Get him. I would just get it. Give it to me.
Because I'm sweating.
Be able to replace the.
Yeah, because I'm a
It's hot in here.
Nathan Johnson is like
Sort those by
my sister.
Broken. Did you hear me? Computer's playing.
And it went online. And it was like,
I'm trying.
Whoa, Lizzie.
Gracie, it's not pointing at you. That's fine.
yes, it is. Bryce wants
Take it back to that part of the room. You can open that. Hey, Lizzie.
Oh, look at that.
This goes to that, goes to that corner.
Lizzie, just like she got you. I know.
Where's your little thing?
The king. I'm in a lot of that film right there. Oh, no.
Sixth grade class, make sure that you are listening to definitions and explanations.
And
John,
preparing
can you
some
see that
questions.
there? Every sixth grader should have some type of question ready to ask this group.
Upperclassmen too.
Okay, this is just gonna be an example to show you like how to find measurements on the teeter totter. And this is the fulcrum, which is like the middle part that like balances the teeter totter. These are just gonna be weights, so like a person. And one is gonna be towards the end, and one's gonna be a little bit more up. This one is going to be more up because it's going to be heavier, and I'll explain that in a little bit. And I'm going to label it as M2. And then this one's going to be 75 grams. That's going to be okay, the distance from here to here, the fulcrum to the weight, is unknown. so we're gonna have to figure that out. And distance from the fulcrum to that point is gonna be 12 centimeters. And from here down, that's your force. Okay, and this is actually the same, like from here to here and here to here is actually the same, like forces. Okay, what's given would be, like, you know this, you know what that is, the weight, and that, and you know your measurement. And this is your unknown. Okay. What is also known is that this, from here to here, is equal to that, and there to there, that's equal. Okay, so to figure out your distance, you have to do your weight,
Your fingers covered, dude.
which is M1 times your distance, which is 12 centimeters, and that's going to be equal to that weight, 100 times R2. Okay, since you're putting it, or we have to change this into kilograms instead of grams, so you have to do 0.075 and do 0. Okay. So you have to times these two, and then you have to divide by that, so that cancels out. And then in the end you'll get R2 is equal to 0.09, which you transform into centimeters, which would be 9 centimeters. So your unknown would be 9 centimeters.
Those are the measurements that we use when we actually went to the teeter-totter. That's one outside. The width of it would be 23 inches. The length of it, the whole thing, is 10 feet 7 inches. And the lever centrum, is from the fulcrum to the ground, is 58 inches. There's 3 different types of, there's 2 types of levers. We had the first lever, which would be the first class, so it would be a teeter-totter. So the fulcrum will be in the middle, so that's the first class of the levers. The second class is the rear barrel. So the fulcrum would be in the middle, so that'd be like the wheel. And the third class is like the fishing pole. So I'm not sure, it'd be on the very end, and it's like the reel part. And there's other parts of it. There's a pulley, wheel and axle, a wedge, and some clean.
First class lever, the teeter-totter we observed in the first class lever because the fulcrum is in the center. The advantages of the teeter-totter is that you gain force, and the disadvantages are that the distance from each end. Teeter-totters back then. Kids got hurt more with the teeter-totters back then because the teeter-totters are much more taller and installed on a flat top. They were also made of wood and gave you splinters.
Okay, the way teeter-totters are today is that they're a lot more shorter than they were back then, and a lot less likely to get hurt if you fell off of them because they're on a softer ground. They're also painted over so that you don't get splinters.
No.
Okay. That's how teeter-totter works.
Well, I didn't realize, but after we got done doing the video, I had to scoot up because we tried to balance it, but it wasn't working, so I had to scoot up since I'm heavier than Aurora. So I scooted up, and she stayed towards the very end, and we tried to balance it, and it kind of balanced, but not really, so we just had to figure out how to balance it.
Did you actually try the weight on the teeter-totters?
Yeah, they'll give me or the weights.
Any other questions, sixth graders?
How about the upperclassmen? Did they get everything out of the rubric? Did they leave anything out?
Did you guys understand what they were talking about most of the time?
The whole math and stuff.
Yeah.
Do you understand the math?
No.
It's kind of complicated.
Was there something that you did understand? Brogan, was there something you did understand when she was explaining it?
It pretty much, I just gave you this example so that you could see that if you're heavier and you're on a teeter-totter with somebody who's lighter, you're gonna have to scoot up to even out the weight in the balance. That makes sense?
Laddie, can you draw a teeter-totter up there with 2 boxes on one side and 1 box on the other? Make all the boxes the same size?
Well,
Yep.
he's drawing, how did she prove that if you're heavier, you need to scoot up? How did she prove that? I didn't realize that.
On the one on the left, on the first one she drew, the one on the left, the left box is up farther than the one on the right.
Oh, she drew that. Are there measurements there that show that?
No. Yeah, yes.
The box that weighs 100 grams, 90 millimeters, and one that weighs 75 grams, 12 millimeters.
Good.
Yeah, very good.
And where did that 9 come from? She's got 9 centimeters there, but did she have 9 centimeters when she started?
Get a question.
She had a question mark.
Yeah, she did. She had a
How did
question
she
mark
get the
there.
9?
And how did she get that?
Yeah.
And you should have shown the formula that you used. Because you put numbers in,
Yeah, okay.
but you didn't write feedy further up on top.
Not
It's the same thing.
Those are weird names.
Not argue. That's your formula.
So, Laddie has some blue boxes. If we put 2 6th graders on one side and 1 on the other, can you still teeter-totter?
Yeah, if we could tie on one end and 2 skinny ones on the other end.
Can you pick up your feet? Maybe. What if we pick 3 kids that are all the same size?
They're on the same side, we'll be down on the ground with one.
Is there any way that we can arrange those kids so that they're not down on the ground? Laddie, can you erase the one on the right side and make it balanced? Nope. Erase that one. And now make it balanced for us. It's magic. You can make the board longer. Yeah. Now put your box out there. Would that work? With 3 kids the same size?
Yeah, probably.
The 2 kids are close to the center part. What's the name of the center part? Fulcrum. And the 1 kid is way far out on the end.
Yeah, we'll keep the other side down.
Yeah, would that work, Ty?
Yes.
It could. Could this work if we put the 2 biggest 6th graders on the left side and the 1 smallest 6th grader on the right side?
I'm just
Why not?
That's one weight more than another two.
6th grade? Could you make that work? With the 2 biggest kids on one side and the smallest one on the other? What if the 2 biggest kids were sitting almost on the center part?
Yeah.
And the 1 little kid was way at the end?
Yes.
That might work.
Yeah, good.
Guess what you should try at lunch? Guess what you should try at lunch?
You don't have to do that?
See if you can make that happen and get a picture of it and bring it back.
Okay, I got my phone, so speak. You can do that. That's all.
Upperclassmen, questions for them? Did they have good science? Did they mess anything up? Did they leave anything out? What parts of that could be improved? All right, let's give them a hand.